Unit 6, Lesson 1, Leaping Lizards. We're going to combine together Lesson 1 and 2 in this video, just to kind of show you what's going on. I'm going to jump right to the lizard part of this lesson. There's quite a bit of words here about the kinds of transformations we're going to put the lizard through. Translations or slides, reflections or flips, and rotations or turns. It does give the original points of the lizard, but basically we could just take the points as we see them, and when on number 1 we're asked to translate, that means we're going to move them. Now, how far do we move all the points? The same distance, it says translate the original lizard so that the point at the tip of its nose is located at 2420. So we're basically saying, okay, if his nose moves from A to the A with a little mark on it, and that's read as A prime, you see that on the rock, all the other points are going to move the same distance. So I believe it's something like 8 units up and 10 units across. Every point is going to translate or move the same way or slide the same way for translation. Now, for rotation, this is number 2. The point A is being rotated 90 degrees counterclockwise, and that moves the entire lizard as if it's on a circle, as if each point is on its own separate circle. So it's hard to draw, but that lizard is then pointing in the downward facing orientation. So an orientation is simply a direction that something is facing. The last one is a reflection. So reflections, what they do is they preserve the distance from a line. So this line that you see here, this is called the line of reflection. The distance that the nose is on one side becomes the exact same distance the nose is on the other side. So if I were to, just say do a stick figure of what this lizard might look like, it is going to have its tail curling the other way. So it's going to come through. Here's the body. Here's the tail is going to curve like that. And here's the legs coming out here to the side. Just like everything is backwards when you look into a mirror at home. Now, some takeaways. What these 3 transformations do is they preserve distance and angles within the figure. So in other words, you might take the distance from his nose to his tail. It's the same no matter which of these transformations you put it through. Same for the angles. So that means then the area and the perimeter also stay the same when you do these kind of transformations. So remember, a slide moves all points the same distance in the same direction. A rotation, the points turn on circles the same angle. And for reflection, all points are the same distance, but on the other side of what we call a line of reflection. Now, in our vocabulary box here, you have this interesting abbreviation CPCTC, and that means corresponding parts of congruent triangles are congruent. Basically, what it says is if you have 2 figures that are copies of each other, then their parts or their pieces are copies of each other as well. And let's go on to the next lesson, lesson number 2. So Unit 6, lesson 2. And here we learned a couple of things about parallel lines. First of all, we reviewed the names of triangles. If a triangle is acute, that means that it has all its angles less than 90 degrees. Obtuse means it has all its one of its angles more than 90 degrees. A scalene triangle is a triangle where all the sides are different. An isosceles triangle is a triangle where 2 of the sides are the same length. And equilateral means all the sides are the same length. So we looked at moving these third points on the graph to different places and looked at how that made different kinds of triangles. Then on number 1 here, we tried to identify which lines are parallel to each other. And here's the big takeaway. When lines are parallel, they have the same slope. So what about lines that are perpendicular, meaning lines that meet at 90 degrees to each other? Well, what happens to their x's and y's, or their slopes, you could say, if the slope between A to B is 4 to 2, when we rotate that triangle, let me do that in purple here. So it becomes 4 the other way and 2 the other way, up this way. This is now 4 and 2. So the slope goes through a transformation we call a negative reciprocal. So if the slope originally, let's see, let's do this in part E. If the slope originally was up 4 and over 2, and that is a slope of 2, by the way, then when you look at the perpendicular line, the line that meets it at 90 degrees, it's going to flip upside down, so 2 over 4, and also it's going to be negative. So a positive slope line will always meet at 90 degrees with the correct slope, but it has to be negative. So put a negative on there, it's negative 1/2. Here's a little something to keep in mind. When you multiply a slope times the perpendicular slope, you'll always get the number -1. Okay, that's about it for this. We did do, in the Ready, Set, Go, we did some Pythagorean theorem, and Pythagorean theorem will be on the final exam. But hopefully this catches you up.